First off, thanks very much to the organizers of the conference for giving me this opportunity. It's had some amazing speakers and talks over the course of the conference. So it's a lovely opportunity for me. This is number 2 for me, so I'm doubly lucky. So hopefully you don't mind seeing this ugly mug again. Today I'm actually going to do a preview of a workshop that we're running later in the year as part of the AgileAus conference. So, and this workshop's around building ethical AI systems. It's going to touch on some of the issues that I talked about in my talk yesterday, but that is not going to be a prerequisite, having seen that talk. So, so my name's Lachlan McCalman. I'm the Chief Practitioner at Gradient Institute, and my background's in machine learning research and practice, and I lead the practical implementation and training functions of Gradient Institute's work. So perhaps just a little bit about Gradient Institute itself. We're an independent and not-for-profit research institute, and our goal is really to bridge the gap between sort of high-level ethical principles and concrete implementation of AI systems in code. How do we make these systems actually behave in a way that's in accordance with our ethical intent? And in order to do that, we do research into machine learning, we do practical application and training, and we also try to influence policy and regulation. We've only been around for about a year. Gradient Institute was announced in December 2018 by a joint press release between IAG, University of Sydney, and Data61, Cyrus Data61, and we started operating with their support in July 2019. So we're just coming up on our first birthday. Now, this training course that we're running in October as part of Agile Australia is an example of a number of training courses that we run both for technical people, data scientists, people who use models for a living in an organization, domain experts, and also leadership. So that's a big part of our work, and I encourage you to contact us if that's something that's of interest. But, and of course, definitely sign up for the workshop in October. So let's talk about the course then. So it's going to be, the conference runs 12 to 13 October. Provisionally, I think I'll let the organizer speak to that, but currently the dates for the workshop itself are Melbourne on the 14th of October and Sydney on the 16th. So this is an introductory course, but it's very much going to have a practical focus. So we're going to go through technical concepts, and I'm going to actually just take a snapshot of the course, and we're going to look at some of the work that you'll do in the course now. But you don't necessarily have to have a technical background. So we're not going to be expecting you to be a machine learner or a data scientist necessarily. But hopefully even those people might find it interesting. So in terms of the course outline, for those of you that saw my presentation yesterday, it's really going to try and touch on a lot of those issues that I raised about how we build AI systems to act in accordance with our intent. We want to have a really practical focus. So the format of this is interactive notebooks where the participants take on activities, interspersed with presentation from our tutor and tutors, one of which is me, and discussion. So the topics include automated decision-making, quantifying intent, which is I spoke quite a lot about yesterday. And the one that we're going to dive into today is algorithmic bias and fair machine learning. We also talk about interpretability, transparency, and accountability, as tools for ensuring your systems are operating ethically. So let's jump in. What I'm going to do is actually just show the notebook itself. If you'll permit me for a second, I'm just going to reshare my screen. I think there's a little issue with the gray overlay here. So just hold your horses for 1 second. Okay, so we're going to look at algorithmic fairness today. And this is not the first module that we do in the course, but I think it's a really nice example of the kind of work that you're asked to do in the course. And also it touches on a lot of the issues that I talked about yesterday. And so we can, I'll tie it back to that talk as well for those of you that saw that talk. So algorithmic fairness is really about attempting to move from the ethical notion of fairness to a precise mathematical statement about a system's behavior or its operation that allows us to actually constrain its behavior. We can't ask an AI system to be fair. We can only describe a precise mathematical objective or constraint which encodes the notion of be fair that we want to have in our minds. It's immediately obvious then that there's many possible ways to interpret the idea of being fair that are very context specific. They depend on the system that we're working on. They depend on the particular impact. And so we have a lot of cases where we have to think carefully about the details rather than just sort of mathematically solve fairness and here's the equation. So this is what we're going to do today. We're going to look at a particular scenario similar to the one we saw yesterday, but not the same. So this is a system that is actually in use a lot in virtually every bank, which is one to do credit scoring. So this is the question around, should we offer a loan to an individual when they apply for that loan? Now, the way this system works is we want to give loans to people who can pay them back, and we don't want to give loans to people who will default on those loans. So the machine learning or the AI-based approach to this problem is to take historical customers for which you know the outcomes. This person successfully repaid the loan, this person did not, and to train a model to predict for new customers whether the model believes the person would default or not. So what we can do is create a machine learning classifier that predicts the probability of suitability, if you like, the probability of paying back the loan. We can then rank people on that probability and threshold, and everyone above the certain threshold, we can offer a loan. So in this example, we're going to keep things simple and say the benefit to us if we offer a loan is $1,000. We get that in interest, but the cost of offering a loan to a customer who goes on to default is $2,500. So we pay a big penalty when a customer defaults. And what we're going to do is we're going to simulate the effect of our system. The problem, of course, when we're trying to estimate the fairness of a real system is we have predictions about whether someone has repaid the loan, but of course we don't know whether that prediction is true. So in order to validate our system, we have to perform this analysis on historical customers. We can estimate the fairness of our current system, but we know for sure that we're doing what we're doing once we've got outcomes. Okay, so let's start just by examining, before we even look at fairness, let's just examine how this system is actually working. So what we've got here on the two plots here, let's start with the one on the right. On the x-axis, we've got the score. So this is like the probability that someone will repay, if you like. Down at 0, they're very unlikely to repay. Up at 100, they're very likely to repay. But note, this is a prediction, and it has, so therefore it's not perfect. What we're plotting here is a histogram giving the number of people who repaid or didn't repay, defaulted, as a function of this score. So what we're seeing is that our system is able to separate people reasonably well. Most of the people that repaid are kind of up this end on the right, and most of the people that didn't repay are down this end on the left. But even up at high scores where we believe that people are very probable to repay, we're still getting some defaults here, and you can see that in the small red markers. On the right is how we calculate the profit, which is really just to multiply the number of repaid people by the amount we get. And what we can do here is change our threshold. So you can see all the bars that are filled in, they're people that we've selected for the loan. the grayed out bars are people that we haven't selected for the loan. So you can see up here now, I've selected no one for the loan because my threshold's so high that no one actually reaches it. And down here, I've given everyone a loan. Now, both of those seem like bad ideas if I want to make a profit, right? The one up the top here, I don't get any loans, so my income and expense is exactly zero. If I give everyone a loan, then you can see that I make a substantial loss just because of the sheer number of defaults. Everyone in the cohort now that is going to default will have received a loan. So the first question about the maximum profit you can achieve with this system, we can read that off pretty well straight from the graph. And we can see that a threshold here of about 60 is what balances the trade-off between getting lots of green, because we make money on green, and avoiding as much red as possible because we lose money on red. And then B, this really explains why there's a sweet spot. If we go too much further to the right, we're not getting enough good loans. We're being too conservative. And if we go too far to the left, we're getting too many bad loans, and so we're losing money. So we can get that sweet spot there. So the next question then is, how would the plot on the right change if the AI system was more accurate in its predictions? Well, I think everyone's on mute, so I won't call out, but I think if anyone has an intuition about this, you can imagine that the separation between these two hills will get further away. These greens will bunch further up towards 95, and these reds will bunch further down towards 0. If we had a more accurate model, then we would be making fewer mistakes. In other words, these bars up at around the 80, the red bars would be smaller because we're assigning the correct probability of default to people. And that's an important concept that we're going to come back to in fairness, is that when we start making trade-offs, and here we're talking even just about a simple trade-off between profit and loss, having a better model often makes those trade-offs more favorable. All right, so far we haven't talked about fairness. We've just given an overview of how the system works. Now let's now start talking about fairness. So what we're going to do is we're going to ask the following question: how does my system treat men and women differently? And we're going to look at what are the relevant differences there, and therefore what harms and benefits are we distributing unequally to men and women by the use of this system. So the first step to doing that, we can just do exactly the same plot of what we did, but we can do it separately for men and women. So here I've plotted exactly that. You can see the male outcomes on the left and the female outcomes on the right. So what I think some of you might notice immediately that these two plots are different. So the first question is, what are the potential problems that you see with this distribution? So we would see straight away that, look at the separation between the green and the red areas for males compared to females. The male outcomes are really well separated. These are indicating that our model is very accurate on males, right? We're able to differentiate between people who will repay and people who will default. But in the female outcomes, it's less, they're less separated. They're more mixed together. Both peaks are closer to the middle. And this tells us that for females, our model is less accurate. Now this presents us already a challenge for how we're going to ensure fairness. So you might ask, why would this happen? That happens to be the second question. Why would we see this kind of effect? Well, there's a few possible reasons. So one reason is to do with the number of men and women in our data set. Generally speaking, a machine learning model gets better when you provide it more data. So if there's more males than females applying for our loans historically, then we'll have more male data, and the system will be able to make more accurate predictions as a result. Another possibility is that the features that we collect, the way we ask the questions about credit score and the things that we use to calculate, to give to the model to create credit score, better capture male risk behavior compared to female risk behavior. So this might be that we're asking, there's some key questions that we're asking that that are more effective at finding out the male credit risk than the female credit risk. So that's another possibility as well. It could also, a third possibility is that there's, because of the differences in the sort of life journey of many men and women statistically, obviously women take time off work to have children in some cases, men do too, but to a lesser extent, that there may mean that this system is, that these outcomes are harder to predict as a result of some difference there in the world. And most likely it's going to be a combination of these factors. Now, we've simulated this data in order to illustrate the fairness challenges that come up. But this kind of thing is extremely common in real data sets in the world. It's very unlikely that if you break down a group like men and women, or old people and young people, or people with high incomes and low incomes, very unlikely that you would actually see the model having the same level of performance on those groups. And that presents some fundamental challenges to us for ensuring fairness in a model. So we've now got a way to evaluate the model's performance separately for the males and the females. Let's start looking at some fairness metrics. So we're going to talk about a couple of metrics here, 3 metrics actually. The first one we'll talk about is demographic parity. So this is a measure that just asks the question, how many loans did you give out to men versus women? So this is just the ratio of the number of selected people to the total number of people. So if out of the 1,000 women in the cohort, I gave out 500 loans, and similarly out of 1,000 people, 1,000 men, I gave out 500 loans, then my demographic parity is 1 because they're the same ratio. This is one measure of fairness that just relies on kind of equal treatment based assumptions. We want to make sure that if we're giving out loans, then we should give them out at the same rate. Now, in our example, men and women actually do pay back loans at the same rate. This is called the base rate of the system. So demographic parity would actually be a reasonable measure in this case. In some circumstances, when the base rate is different, that measure of demographic parity might be less appropriate because it doesn't take into account whether our decision to select an individual was a good decision, whether that person actually defaulted or not. And so if we want to take that into account, there's really kind of 2 main ways that are relevant to this problem. The first is equal opportunity. And this is asking the question, of the people that would have repaid the loan, so of all the green people in this plot, for example, of all the green people, how many did you actually give loans to? So if we look up here, we're saying of all these green people in the top curve, what fraction of them were selected? What fraction of them are bright green? And the ones that are light green missed out, even though they would have repaid. So this is a real harm. It's an opportunity harm, you can say, where someone is looking for credit, they applied to get the loan, they can repay the loan, they're good for it, and yet your system doesn't select them. So that's a harm that we want to understand how it's distributed between men and women. There's a different kind of harm, and that harm focuses on these selected red individuals here at the bottom. So these are people that you gave a loan despite the fact that they couldn't pay it back and they ended up defaulting. Now, a defaulting situation where you're provided a loan can be really damaging to people. So this is another harm that we want to understand here. So these three measures are going to encompass the three harm and benefit considerations that we're worrying about. So now let's set ourselves to maximum profit. So that's going to be roughly here where we are. Maximum profit is $471,000. And let's look at these fairness measures. So we can see here, let's look at equal opportunity first. We can see we're definitely not being fair on equal opportunity measures. Look at the ratio here is 0.63. We can see that of all the men who would repay, we're giving quite a high percentage compared to the women that can repay. That looks like almost 50% of the women are missing out. So at the moment, this is really quite unfair to women in regard to this measure. We can see similarly that precision parity, we're also suffering here. We have very few loans proportionally are being defaulted amongst the men, but proportionally, based on the size of the number of female loans, then we're seeing a substantial fraction of those defaulting. So not only are we skipping women that we should have given loans, but we're also giving out loans that we shouldn't be to women. And also we can see demographic parity, we're giving women slightly fewer loans. So this means that we're currently not being fair at all, but we can move our system to change the threshold to try and improve things a bit. So let's say we move the threshold down to say, if we want to get a selection threshold within 15% of parity while still remaining profitable. Well, let's just try it for equal opportunity. So we're at max profit now. We can increase. The problem that we're seeing here, right, is that we're not giving out enough loans to women. So the only way for us to give out more loans is to lower the threshold down here and give out more loans to women. You can see now we're capturing more women. So we can keep moving until we get to 0.86. So that's within now 15% parity of our equal opportunity. But notice we're still unfair with precision parity, and we'll get back to that later. But also we're seeing that we're now making a profit of roughly 3/5 of what we were making before, or even less. We've paid a substantial cost in the profitability of the system in order to achieve this result. And you can kind of see intuitively why this would be the case, because in order for us to reduce the threshold, as we did, to include more women here, because our system's not very good at predicting women, we also get a large number of defaults from women. And that's actually increasing our the harm here associated with precision parity. So this seems like nobody wins really here. The system is much less effective, and also we're incurring a large cost in terms of precision parity. Now, we can do a little bit better than that if we want to improve the fairness of the system. But our only choice now is to start separately setting thresholds for men and women. And this comes in, so we're now no longer treating men and women equally. We're now having to account for the fact that our model is less accurate on women and compensate for that as a result. So now we've got two levers. We've got the male threshold lever here, and we've got the female threshold lever here. So now it's with these two degrees of freedom, it's now possible for us to achieve perfect equal opportunity. So let's try and get something very close. Okay, that's very close now, 1.054. So if equal opportunity was our goal, we could achieve it now precisely by moving these levers accordingly. And so now we can see that males who are able to repay are actually 5.4% less likely to be offered a loan. So small difference, we're basically close in terms of the harm of opportunities lost from loans that we should have provided. But we still have a big problem here in precision parity, where now females who are offered a loan are 800% more likely to default on it. This is a big disparity. So we may need to address this. So the only way to address it, of course, is to reduce the number of females getting loans to get a better precision parity. And we can do that. We'll probably have to increase the number of defaults as well of males in order to get that value. So now you can see we're fairly close to precision parity, but we're actually giving out a tiny number of loans to women. Females are 96% less likely to be offered a loan. So it seems like we can't win. And question 5 here, can we satisfy them both simultaneously? The answer is no. Because of this fundamental difference in our ability to predict, we will never be able to satisfy these two measures simultaneously. We will have to make trade-offs. And this applies in very, very many cases. There's only a few cases where you can satisfy these kinds of measures simultaneously. One is when you give loans to everyone. One is when you give loans to no one. And one is where the base rate and your ability to predict are both identical. In other words, there's absolutely no difference that the model can see between the two groups. So those are the only conditions. In general, we have this problem. So how do we proceed? Well, as I spoke about in the last talk, pardon me, my dog is obviously spotted the postman. As I spoke about in my last talk, what we have here is a fundamental trade-off that we have to understand and balance. So let's visualize that trade-off. We kind of have two degrees of freedom. We have a degree of freedom which allows us to vary the male threshold here, this lever, and we have another degree of freedom that allows us to vary the female threshold. So what we can do is we can do a 2D plot, which gives us the landscape of trade-offs that we're looking at. So on the y-axis here, we're looking at the female threshold, the female loan threshold, and on the x-axis, we're looking at the male loan threshold. So any point on this plot is a choice, is a model that we could potentially make. Now, let's start off just by moving our point. So here's our current model here. Let's try and model something that's a bit closer to max profit. Okay, so now we're here. So you can see that we've got 4 things plotted on this. This is a reasonably complicated plot. The first thing we've got are contour lines that represent profit. So you can see this point here. This is our max profit, 498K. And that corresponds to having a slightly lower threshold for men than for women. And that, again, is intuitive because we're better at predicting men. So when we lower our threshold, we get fewer bad loans in the male cohort as a result. Overlaid on this, we've also looked at the areas that will satisfy our different kinds of fairness measures. So the first being precision parity. So all this orange area, any choice in this orange area is going to satisfy precision parity. Any choice in this gray area is going to satisfy demographic parity. And in the equal opportunity is the purple area. Now, if we were wanting to perfectly satisfy these, they would be lines. And I think these areas represent a 5% deviation either way. So we've given ourselves a little slack here. So the first thing you notice is that we can now see really clearly that statement that we understood before, that you can't satisfy these measures simultaneously, is true. There's nowhere here, apart from down right in the corner where we're giving loans to everyone, where all of these measures really overlap. I mean, the closest area is where we're making a $500,000 loss. So that's not really an option to us if we want the system to function. And it's worth pointing out there that even though we're satisfying all of the measures, our default rates down here are going to be extremely high, and we're going to be doing a lot of harm by giving out a lot of bad loans. So what we have now is a challenge for the decision makers and the governance of this system. What compromises are we going to make here? And there's a few ways to look at this question. How do the harms that we're capturing by precision parity, which are related to defaults, compare to the harms that we're capturing in equal opportunity that relate to missed opportunities? Intuitively, we might think that those defaults are a more serious consideration, and so maybe we should consider points that are perhaps closer to precision parity than equal opportunity. But other arguments for the lost opportunity also may be relevant here, and we might argue that a better choice is to satisfy one of them. All of these things, of course, require us to treat women differently unless we're moving along the line y equals x. So if we have a consistency of treatment goal, then we might have to select a point along that line. And we can see here that, at least in the short term, the cost of achieving some of these measures is non-trivial. So, for example, we lose 100K if we want to get to precision parity from our maximum profit. So this is now the fundamental question that we're left with. But it doesn't end here. What do we do? Well, the first thing that we should realize is that a lot of the troubles here relate to the fact that we don't have very good data on women. That we should consider it a high priority to get more data. And if we do that, if we improve the trade-off, then we can separate these two curves a bit more in females. And you can see that our new trade-off landscape is actually much more favorable. We're now not only are we making more profit because we're now better able to predict women, but we're now actually closer to being able to satisfy more of these fairness measures at the point of max profit. So everybody has won by us collecting more data in this case. So this is a really important observation, that it's not just about the trade-offs that you're stuck with, right? You can go out and actually do something to make it better for everyone. And notice here that we made it fairer and got more profit. So that this is a really good outcome if we can do that. So I'm going to wrap up now just with some final notes, and then we should open to questions, if that's all right. Just allow me to reshare my screen. Okay, so just very briefly, the takeaways here. If we want to make a fair AI system, we have to quantify what fair means. But what that means is really context specific. It's not enough to just say, oh, fair means equal opportunity. We have to consider carefully the harms and benefits associated with our particular system. And there's a trade-off there between fairness and our primary objective. But note that that trade-off may be short-term. If we, for example, take a hit to our system and provide women with more loans to improve equal opportunity, then as a result, we will be getting more data about women, and in the long term, our system will improve that way. So we should be very aware of both of long-term harms and of feedback effects. There's some really important work that shows that even if you satisfy some of these measures in the short term, long-term feedback behavior, the fact that repaying a loan makes it easier to get a loan in the future, and that defaulting makes it harder to get a loan in the future, can still lead to outcomes where we're seeing an increase in the systematic disadvantage between the groups. So this is a really important idea. All right, that's enough. So I think that gives you a good idea of the kind of work that what you're going to see in the workshop, and I hope it was interesting in its own right as well. In the real deal, you'll be answering the questions, so and we'll be there to help you. But now, for the rest of my time, I'd like to open it up to any questions that you might have.
Wonderful. Thank you so much, Lachlan. That hurt my head, but again, in a good way. Thank you. So we do have a question here from Andrew Sims, just saying, are there examples of societies or companies reframing the red in terms of social good? For example, more farmers remaining on their farms. Good
question. So I mean, I'll say first off that I'm not an expert in the sort of the credit scoring use case per se. So the short answer is I don't really know. But to the extent that I have talked to the banks, it's certainly the case that the question of how to deal with what they call delinquency or defaults is a complex one. And as you say, there are social benefits from taking particular actions when someone is unable to repay a loan. And this analysis does not include those other measures, right? We're to have a very simplistic model where someone either defaults or they don't. But in reality, as you say, there's a much more nuanced question of how we minimize and manage those harms.
Great. Thank you, Lachlan. I think that actually brings us to time. We better leave it there. But I'd just like to thank you so much again for sharing such a thought-provoking perspective to finish off Responsible Tech Summit. Thank you. Please put your hands together, everyone.
Thank you very much.
Thank you.